So it's haloalkanes, that is, chapter 10. That is chapter 10, and this is from 12th class. So what this chapter is called? This is called Haloalkanes and Haloarenes. So this is what the chapter name is. We need to start right from the beginning at what haloalkanes and haloarenes are. So today's video, you need to understand that this is the the first segment of the haloalkanes, where I would be discussing about what that mean, what are haloalkanes and haloarenes. The second thing I will be discussing about how many types of the classification, I should say. So the second thing is going to be classification. So classification of both. What both is? Haloalkanes and haloarenes. So these are the today's topic that I will be concentrating on, because they will take more than 20 or 30 minutes or something. I will try to make it fast, though I'm a little bit slow. You do have understood already that I'm a bit slow. So let's talk about what this haloalkane and haloarenes are. So what haloalkanes and haloarenes are? These are the compounds. These are the compounds formed by the replacement of one or more hydrogen atoms from alkanes. So in simple, the compounds that are formed by the replacement of one or more hydrogen atoms from alkanes or arenes. What arenes here is I'm talking about benzene. So what that means? Let's take example so that you get to know what the definition means here. Suppose I'm talking about ethane, right? So ethane, this is what ethane is. I hope you do understand. So there are 6 hydrogen, but in case you replace one of the hydrogen by a halogen, so this is called haloalkane. Now similarly, if you replace one of the hydrogen from benzene, this is called haloarene. So this is your haloalkane, and this is your haloarene. Right? Okay, let me repeat it back. When one or more hydrogen from alkane is replaced by halogen, it is called haloalkane, and one or more hydrogen when replaced from benzene, it is called haloarene. So this is what the definition is. But let's talk about what is the classification of the haloalkanes and haloarenes. Classification, right? But before I come to that, I want you to understand about one thing, and that is hybridization. You need to understand that hybridization is going to be something very important. Hybridization. Please ignore if I'm making a bit of spelling mistakes and all, because I don't care much about it. So hybridization, what the hybridization is, in simple, it's called intermixing of two or more hybrid orbitals or atomic orbitals. Two or more atomic orbitals of similar energy. I'm not going deep into that, so let me wind this up. So what hybridization is? Hybridization refers to intermixing of two or more orbitals with similar energy. What is the concern behind taking this topic right here? I'm coming to that, but before that, I'm giving you a very short formula for hybridization. For any compound, you can find out the hybridization based on the formula I'm about to mention. So hybridization is equal to number of hybrid orbitals. Number of hybrid orbitals. And what number of hybrid orbitals is? Number of sigma bonds plus number of lone pairs pairs around the central atom. Around the central atom in a molecule. In a molecule of compound. So that hybridization is going to be really very important because I'll be using hybridization and classifying. But before that, I'm just trying to make you understand that what hybridization is. Hybridization means intermixing of two or more orbitals with similar energy. How you can find out hybridization? By counting the number of hybrid orbitals. And how number of hybrid orbitals are counted? They are equal to number of sigma bonds and plus number of lone pair around the central atom. You need to understand that is equal to sigma bond plus lone pair around the central atom in a compound. Let's take an example. Suppose I'm talking about, CH3Cl. So this is chloromethane, right? So if you draw the structure, this is what the structure is going to be. I usually have no habit of, writing the hydrogen. So I'm just ignoring all that. So how many sigma bond is here? There are 1, 2, 3, and 4. So this particular molecule has a hybridization of, this particular molecule has 4 hybrid orbitals. You need to understand that it talks about the 4 hybrid orbitals. This is the 4 hybrid orbital. 4 hybrid orbitals. I'm sorry, I'm not taking further more into that because that's changed the whole topic. 4 hybrid orbitals and 4 hybrid orbitals because there are 4 sigma bond 1, 2, 3, 4 and 4 hybrid orbitals. They start with S. The next 3 is going to be P3. So this molecule has a hybridization of sp3. Right? Let's take another example. Suppose I'm talking about C2H4. So C2H4 has a structure of something like this. It has a structure something like this. So what we see that both of the carbon has 3 hybrid orbitals involved. 1, 2 and 3. I hope you understand that a double bond has a sigma and a pi bond. So this involves 3 hybrid orbitals around each carbon. So the hybridization is going to be sp2. Let me go back there and explain you a bit more. I repeat, there is one sigma bond here. Sigma bond has a symbol something like this. There is another sigma bond here, and in double bond there is one sigma bond. So what we see that around each carbon there are 3 sigma bond. So 1, 2, 3, 1, 2, 3. Another one is a pi bond. So basically the concern is related to sigma bond and lone pair. There is no lone pair, so I'm not counting that. So therefore the hybridization of C2H4 is having sp2. Let's take another example. Suppose I'm talking about C2H2. This is ethine, and if you draw the structure, you do understand that there is a triple bond here, and because it has a triple bond, so its hybridization is going to be 1 and 2. There are only 2 sigma bond. So 2 sigma bond, I write something like 2 hybrid orbitals. 2 hybrid orbitals. And if there are 2 hybrid orbitals, definitely the hybridization is going to be sp. So this is what something we had to do before we even start the haloalkanes and haloarenes classification. Okay, so I hope you have understood because these are really very important. These are very basic, and once you are done with that, then you can start with other things coming up in the haloalkanes and haloarenes. So now I'm talking about the classification. So classification of haloalkane and haloarenes. Right? Haloalkane HA, I'm representing haloarene with HAR. Okay, so the first one is that carbon having sp3 hybridization to which halogen is bonded. Halogen is bonded. So the first level of classification say that if the carbon is having sp3 hybridization, especially to the carbon to which halogen is bonded, then we can classify the first one. So what based on sp3 hybridization, the classification coming out to be, the first one is called here alkyl halide. This first one is called alkyl halide. So what this alkyl halide is, the carbon to which halogen is bonded must have a sp3 hybridization, sp3 hybridization. You need to understand that this one has a hybridization of sp3. As you can see, there are 4 sigma bonds, 1, 2, 3, and 4. So alkyl halide is the one which have a hybridization of sp3, especially with the carbon to which the halogen is bonded. Now, one more thing: if this alkyl halide, where the carbon is bonded to one carbon, it's called 1 degree, or you do know it's also called primary. It's called primary because the carbon to which halogen is bonded to one carbon. So this is called primary haloalkane. Let's talk about another type here. The another type is like this. So the carbon, to which halogen is bonded have a hybridization of sp3. But if this is bonded to two different carbon, this is called 2 degree. This is called 2 degree or secondary hydrocarbon. Right? Again, let's talk about the third one. If there are 3 carbon, but the hybridization of the carbon is sp3 to which the halogen is bonded, then this is called the tertiary one. This is called the tertiary. In short, you can write T-E-R-T. So it's tertiary. So there are 3 types of alkyl halide: primary, secondary, and tertiary alkyl halide. These are all alkyl halide. They all have hybridization of sp3, but because number of carbon bonded to the carbon to which halogen is bonded is 1, 2, and 3, therefore they are called 1 degree, 2 degree, and 3 degree, alkyl halide. Okay, what next classification can be done? You need to understand that I'm talking about, mono di and tri. What mono di and tri means here? If there are only one halogen, this is called mono. This is called mono haloalkane. Mono haloalkane. Similarly, if there are two halogen, if there are 2 halogen like that, it's of course dihaloalkane. It's called dihaloalkane. Let's talk about the third one. If there are 3 halogen on 3 different or anywhere, so if there are 3 halogen, this will be called trihaloalkane. Trihaloalkane. So these are called alkyl halides. So alkyl halides are of basically 2 types. Alkyl halide. They may be either 1 degree, 2 degree, or 3 degree. They may be either mono, di, or trihaloalkane. So allylic halide. The second one is allylic halide. What allylic halide is? Carbon to which halogen is bonded has sp3 hybridization. But it is next to double bond. You need to understand, next to carbon-carbon double bond. Let's take example here. This is what allylic halide is. So what you see out here, that this one has a hybridization of sp3, but the adjacent carbon has a double bond. So this is the kind of haloalkane which is called allylic halide. So this is called allylic halide. Another example what we can take is like, suppose like that. So this is also an allylic halide where carbon is having sp3 hybridization, but the next carbon to which it is bonded is having a double bond. So these two are an example of allylic halide. Let me repeat back. Carbon to which halogen is bonded should have a sp3 hybridization, but the carbon to which that carbon is bonded should have a carbon-carbon double bond. What that means? This has a hybridization of sp2. Let me repeat. This has a hybridization of sp2, but this is not the only thing you need to consider. sp2 here. Right? So this is called allylic halide. You need to remember the definition here. I'm taking the third one about benzylic halide. What benzylic halide is? Benzylic halide. This is the third one. So benzylic halide refers to, carbon to which halogen is bonded carbon to which halogen is bonded has sp3 hybridization, but it is bonded to benzene. It is bonded to benzene. So what an example is going to be? This is going to be like something similar to this. So this is a benzene. However, the carbon to which halogen is bonded is having sp3 hybridization. This is having a sp3 hybridization. So this is called benzylic, where the carbon to which the halogen is bonded has sp3 hybridization, but that carbon is bonded to benzene directly. So this is benzylic. Let's talk about the fourth one. The fourth one is vinylic. You need to understand what vinylic means here. Before that, let's take another example for this. This is also a case of, benzylic halide. Their hydrogen may be, but they can also be like carbon. But this should also have a hybridization of sp3. So this is what benzylic halide is. Let's do the fourth one. Fourth one is vinylic. Vinylic halide. Right? Now you need to understand that the carbon to which halogen is bonded has sp2 hybridization here. Now this is something important. Earlier it was only sp3, but right now it's going to be sp2 hybridization. Has sp2 hybridization, and it may be open structure or closed. Open or closed structure. Something like this. Let's talk about. Suppose, this is what I'm talking. So this is the condition where the carbon to which halogen is bonded has a sp2 hybridization. This one has a sp2 hybridization. This is called vinylic. Another example that can be taken here is like this one. So this is also a vinylic halide. Why? Because this one has a hybridization of sp2. Okay, we have one more sort here. So let's do that also. It's called aryl halide. Aryl halide. What aryl halide is? When halogen is bonded to X is bonded to benzene. X is bonded to benzene directly. So what that mean? This is what the aryl halide may be. This is aryl halide. What is here? The hybridization is going to be sp2. So when halogen is directly bonded to benzene, it is called aryl halide, where the hybridization of the carbon to which halogen is bonded is called is sp2. So this is what aryl halides are. Now what I'm interested in doing, I will talk to you about nomenclature, because that is the next section coming up, but not right now. I'll take this in another video. I hope you have understood what are haloalkanes, how they are classified, what is hybridization, what is the role of the hybridization in the classification of the haloalkanes, right? So with that, I've come to an end of this video. If you have liked, whatever I just said, what you need to do is to, express yourself, express your feeling for, what you just felt about. And that's it. Thanks for watching.